Enormous, mysterious phenomena drift within the vast expanse of space, a subject that has always stirred curiosity and left many questions unanswered. Yet, the moment has arrived for a dramatic shift in understanding. The James Webb Telescope has provided us with a glimpse into what exists within these colossal enigmatic masses, commonly known as black holes. Join us as we venture into the far reaches of one of these dark realms to explore what lies beneath the surface. If you wish to stay informed with the latest cosmic updates, make sure to subscribe to our channel. Don't forget to like, share, and activate the notification bell so more people can join in on this cosmic journey. The story began in 1916 with Albert Einstein's theory of general relativity. Einstein was the first to predict the existence of such objects, although the term black hole wouldn't be coined until 50 years later. At the time, some scientists were on board with his theory, while others were skeptical. It wasn't until the late 1960s, during studies of the star system Cygnus X1, that researchers stumbled upon something incredible. A peculiar bright blue star was emitting X-rays, which hinted at something far from ordinary. This star was revolving around a massive, dark object. Upon closer inspection, they realized that the X-rays weren't being produced by the star but were being drawn towards the mysterious entity it orbited. What lay at the heart of that orbit proved to be an overwhelming force, consuming everything in its path. This marked the first solid evidence in science that black holes indeed existed. Little did anyone know, this discovery was just the beginning of something far more extraordinary. The initial identification of Cygnus X1 triggered a cascade of further findings. It was soon determined that there could be up to 100 million black holes in our Milky Way galaxy alone. However, detecting them is exceedingly difficult, so the precise number remains elusive. Present estimates suggest the number might run into the millions, making these objects even more significant in the study of astrophysics. Most physicists today describe black holes as entities where any matter that crosses their threshold gets crushed to an unimaginable density, eventually collapsing into what's known as a singularity. To simplify, it's been explained that if someone were to fall into one, their body would be stretched out like spaghetti, slowly disintegrating in this elongated form before reaching the final state of collapse. This is one of the most terrifying aspects of black hole research and why so many are intrigued by these dark phenomena. Despite the closest black hole being situated 500 light-years away, the question still lingers. Can these black holes devour the Earth entirely? In 2021, a milestone in black hole research was reached when scientists successfully captured the first clear image of a black hole, specifically the one in the galaxy M87. They photographed the black hole over several consecutive nights, each time collecting more evidence that eventually revealed the existence of 3 key layers in its structure. That's right, black holes are not mere voids but complex entities with multiple layers that need to be explored. To understand them better, let's break down the first 2 layers. First, there is the outer event horizon, a boundary surrounding the entrance to the black hole. Once an object crosses this threshold, escape becomes impossible, and it either gets trapped there or is drawn deeper toward the singularity at the center. The singularity itself is the black hole's central core, where gravity is so overwhelming and constant that not even light can escape. To overcome this force, an object would need to travel faster than light, an impossible feat by our current understanding of physics. It's essential to remember that gravity on Earth operates in a way vastly different from that at a black hole. Were Earth's gravity similar to that of a black hole, life as we know it would cease to exist. Once an object crosses the event horizon, it faces the immense gravitational forces leading to the singularity. The singularity itself represents the point where most of the mass of the black hole is concentrated, and where the laws of physics as we understand them cease to function. Inside black holes, chaos reigns, and even the concept of time becomes distorted. What makes the study of black holes so intriguing is that no two are alike. Each black hole has its own unique gravitational signature and force of attraction. Studying one black hole might give you a wealth of knowledge, but exploring another could require an entirely new approach. It's an ongoing puzzle that never seems to have a definite answer. The challenge for scientists lies in the fact that black holes can't be studied in the same way stars or other celestial bodies are. Unlike stars, which emit radiation and have detectable dust and gas surrounding them, black holes cannot be observed directly. Sending a probe into one is out of the question, as it would be crushed the moment it reaches the singularity. This means that our understanding of these cosmic giants is constrained by our inability to study them in person. The only option left is to observe black holes from a distance, using their effects on nearby objects and light to infer their properties. Despite these challenges, scientists have generated a variety of theories about what might exist inside a black hole. One of the most intriguing possibilities is that black holes might not simply be voids, but rather gateways to other realms. According to this hypothesis, black holes could act as portals that allow for travel between galaxies, or even between entire universes. Another fascinating idea is that black holes could be anomalies in a simulated universe, akin to a glitch in the Matrix. If we ever develop technology capable of faster-than-light travel, perhaps these black holes could serve as shortcuts to distant corners of the universe. But, for now, these theories remain speculative, and scientists are still searching for more concrete answers. Could the singularity be more than just an empty void? Could it lead to a wormhole, a shortcut to another galaxy? If this idea proves correct, it would revolutionize our understanding of interstellar travel and open up the possibility of exploring galaxies far beyond our own. If black holes are truly pathways to other galaxies, it would mean that many of the limitations once thought insurmountable in space exploration may not be as impossible as they seemed. On the flip side of the theoretical spectrum, there are those who reject the notion of black holes altogether. A team of scientists, led by Tokyo-based researcher Enrico Raldi, has proposed a radical new theory. Black holes could be nothing more than holograms. In this case, a hologram is not just a projected image but any optical illusion or discrepancy. Given the sheer vastness of space and the unexplored nature of the cosmos, anything is possible. What do you think? Feel free to share your thoughts in the comments. If you enjoyed the video, remember to like it and subscribe for more updates. The notion that black holes could be holograms may seem far-fetched, but it challenges everything we think we know about these cosmic giants. If black holes are, in fact, nothing more than projections, it would mean that our current understanding of space and time could be entirely wrong. This idea is based on the concept of quantum mechanics, which suggests that the universe might not be as straightforward as we assume. In this model, the universe could be operating on a level that our senses can't perceive, and black holes might simply be an illusion we've yet to fully comprehend. However, regardless of the theory, one thing is certain. Black holes continue to captivate the imagination of both scientists and the general public. Their immense power, the mystery surrounding their nature, and the potential they hold for revealing the secrets of the universe make them one of the most fascinating subjects in modern astrophysics. As we continue to gather more data from instruments like the James Webb Telescope, the possibilities for what we can learn about these dark, enigmatic objects seem endless. Each new discovery brings us closer to unlocking the mysteries of these cosmic wonders. Even though we've made tremendous progress, black holes still hold many secrets that we are yet to uncover. There's much more to learn about how they form, how they affect the space around them, and what their true nature is. Some scientists even believe that black holes could hold the key to understanding the very fabric of the universe itself, potentially revealing a connection between general relativity and quantum mechanics. A connection that has eluded scientists for decades. In the years ahead, as technology continues to advance, we may finally be able to test some of these theories and begin to understand the true nature of black holes. Until then, they remain a tantalizing mystery that continues to fuel scientific inquiry, inspiring countless minds to look deeper into the cosmos. Whether they are gateways to other dimensions, anomalies in the fabric of space-time, or simply the result of extreme gravitational forces, one thing is clear: the study of black holes will likely lead to some of the most groundbreaking discoveries of our time. As we look to the future, we must also remember that our current understanding is just the beginning. With each new observation and each new theory, we are building a more complete picture of the universe and the incredible phenomena that reside within it. The journey into the depths of black holes is far from over, and as we continue to explore these cosmic mysteries, we may just unlock answers to some of the most profound questions about the nature of existence itself. In the meantime, the search for answers continues. The universe is full of unknowns, and black holes are among the greatest enigmas we have yet to unravel. With continued research and exploration, who knows what the future holds? The study of black holes will undoubtedly remain at the forefront of scientific discovery, pushing the boundaries of human knowledge and understanding for years to come. As the years go by, our exploration of black holes is bound to take us to new, uncharted territories. With the advent of more advanced telescopes and imaging technologies, such as the James Webb Telescope, our ability to peer deeper into the heart of these enigmatic objects will only improve. Each new observation presents fresh opportunities to learn about the universe's most powerful forces. This ongoing journey of discovery might lead to insights that challenge even the most established laws of physics. The fact that black holes appear to defy the basic rules of our reality is what makes them so intriguing. For instance, once something crosses the event horizon, not even light can escape, making it invisible to conventional telescopes. This phenomenon alone has sparked intense debates and inspired a range of theories that question the very fabric of spacetime. What happens inside a black hole? How does time behave under the influence of such extreme gravity? These questions continue to baffle scientists and drive them to develop new methods of research. There is, however, a growing recognition that the study of black holes could one day offer us profound revelations about the universe. These cosmic giants may hold answers to questions we haven't even thought to ask yet. They may be more than just endpoints for collapsing stars. They could be windows into other dimensions or alternative realities. The idea that a black hole could act as a portal to another universe is certainly a possibility that many researchers are considering. But for now, it's still a tantalizing theory with no concrete evidence to support it. Regardless, the very thought that black holes could be linked to the mysteries of the multiverse is enough to fuel scientific curiosity for generations to come. In addition to their potential role as gateways, black holes could also provide clues about the origins of the universe itself. If the Big Bang created the universe, could black holes be the key to understanding its final stages? Could the matter that falls into black holes eventually give rise to new universes, perpetuating an infinite cycle of creation and destruction? While this might sound like science fiction, the possibility is something that scientists are actively exploring. As technology advances, more sophisticated tools and models will emerge, and these theories may come closer to being proven. One of the most exciting aspects of black hole research is that it challenges our fundamental understanding of physics. Concepts such as gravity, time, and space become distorted under the immense pressure of a black hole's singularity. The laws that govern our everyday lives break down when confronted with the extremes of a black hole's core. This gives scientists the rare opportunity to explore the boundaries of known physics and, perhaps, discover entirely new laws that govern the universe. In this sense, black holes are not just objects of fascination, they are laboratories where the very rules of nature are being rewritten. Additionally, black holes also shed light on the nature of dark matter and dark energy, two of the biggest mysteries in astrophysics today. Dark matter and dark energy are believed to make up a vast portion of the universe, yet they remain invisible and undetectable through conventional means. However, black holes interact with their surroundings in ways that could reveal the influence of dark matter and dark energy. By studying how black holes affect the space around them, we may uncover new clues about these elusive components of the universe. As we continue to unravel the complexities of black holes, we are also learning more about the larger cosmic web in which they reside. Black holes are often found at the centers of galaxies, and their behavior can provide valuable insights into the dynamics of entire galaxies. They may even play a crucial role in galaxy formation and evolution. By examining the relationship between black holes and their host galaxies, scientists hope to understand more about the birth, life, and death of galaxies, as well as the role black holes play in shaping the universe as we know it.